Hello everyone, welcome back to Let's Crack J in English, the channel of Unacademy. So let me check my audio and video first, then we will start today. Yes, so seems yes, I'm live. And about audio, audio is also good. All right. So I'll begin today's session. Now this session is about complex numbers and we'll solve a lot of problems of complex number today. I'll try to cover init roots of unity and complex geometry, and I'll try rotation as well within the time limit. So this session is going to be a long session. Let's see how long will it be. I've not decided that. So first let me introduce myself. I am Jeetendra Dixit. I did my BTech from IIT Kanpur, and I have been mentoring IIT-JEE aspirants for the last 11 years. I have worked with various national level institutes in Delhi, Mumbai and Lucknow, and for the past few months I'm working with Unacademy, and I teach mathematics. That's what I have told you, because I'm going to discuss complex numbers. So today's topic I have already told you. Now let's so before the beginning, let me tell you about the new features added to Unacademy's platform and also about the Unacademy subscription. All right. So as you know, Unacademy is India's largest online learning platform, and when you get plus subscription for IIT-JEE, then what are the things you can access, and without subscription, what you can access? Let me tell you that. And one more feature which I was talking about is iconic subscription. So I'll tell you about that iconic subscription also today, and then we will begin the session. So when you get Unacademy's Plus subscription, then you can access daily live classes of all the educators who are teaching on Unacademy, which is physics, chemistry, and maths. All means every educator who is teaching on Unacademy's platform, India's top educators are teaching here. So you can watch anybody's live or recorded sessions, and you can follow them and follow their course, because many courses are going on. So you can join a new course, or you can perhaps follow ongoing course. All right, and you can watch recorded lectures if you miss something. So it's up to you, completely your choice. You have complete freedom. This is unlimited access you are getting when you get plus subscription. All the tests and quizzes going on the platform will be accessible to you. You can appear for all test series. All right, all notes, DPPs, everything will be available. And about these live classes, let me tell you that these live classes are very engaging. Very engaging means you can interact with your educator through chat. You can send your doubts. There are dedicated doubt sessions as well. But you can ask your doubts during the session as well, right? Now you can send images. You can write a question separately. You can chat. Okay, you can write in a chat box also. You can participate in a poll. So overall, it's a very interactive session. But let me tell you about the special classes also, which you can access free without getting the subscription. So a special class is basically, 1 minute guys. Yeah. So a special classes are free. Free means you can attend unlimited special classes on the platform. Just download the Unacademy's app and make your profile, and then access all the unlimited access. So every day there are many special classes going on different topics. So you can attend those classes. Practice sessions are there. Doubt sessions are there. I took a doubt session yesterday, and I'll take a doubt session tomorrow as well at 8:30 p.m. Or so you can ask your doubts there. And I also take at 4 o'clock I take a special classes on various topics, like I have taken on binomial permutations and combination, many sessions on AOD, limits, continuity, and differentiability, and I'll keep taking that. So you can attend these special classes, and these classes are going to be very beneficial for you, because I prepare a lot of questions, lot of good questions to discuss in those classes. All right, so that was about the free classes, and the quiz features also. Quizzes or all unlimited quizzes are free on the platform, so you can attend those quizzes as well, right? So these are the things which you get even without getting the subscription, and after getting the subscription, now the access is unlimited, which I have told you. All right. Now, these are the subscription charges of plus subscription. All right. So you can compare this, and 12 and 24 months. Let me highlight, because these are the best packages we are offering. So for 12 months, you'll have to pay 38,500, and after 10% discount, you'll have to pay this much. Okay, 34,000. So you can use my code to get this 10% discount, and this is 24 months subscription charge. So after paying 10% discount, it is going to be 50,000. So it is just 2,100 per month only. All right, so just 2,100 per month, and you're getting unlimited access. So you can compare. It's not much. This was about the Unacademy's Plus subscription. Now let me introduce Iconic subscription. So what is this Iconic subscription? Iconic subscription is the same like Plus. You get unlimited access, but here you also get a personal coach. Personal, that means a personal tutor will guide you throughout your preparation. You know. So that is a very special thing. That one guidance from top exam experts as your personal coach. All right, to align your preparation strategy. Test analysis will be done deeply. Okay, personalized feedback to improve your time management. So test analysis, personalized test analysis will be there. So you will be told about your areas of improvement and all these things. So you can see how personal attention you're getting in terms of your preparation, in terms of your analysis of test. All right. So all these, your study planner will be given to you. Okay, so it will be customized to you. Study planner, how to manage your hours, how to, okay, so everything. So all these features you are getting by taking Iconic subscription. All right, and all the benefits of Plus, as I told you, whatever you're getting in Plus, those features will already be included. All right, so that will be there, and these are the additional things which I have just added. And how much you need to pay? You just see the price. It's not much. It's just 56,000 for 1 year, and after 10% discount, it is going to be 50,400 only. And for 2 years, it is just 86,000. After 10% discount, it is going to be 27,400 only. Okay, so, and if you take the average, it is just by 3,000 and something. So you're getting personal attention by just paying 3,000 and few bucks per month, and you're getting personal attention by a top educator. All right, so this is about the Iconic subscription. So I hope you have got it, and this is a very interesting feature Unacademy has added to its platform recently. All right, so now you can download. This is Unacademy's learning app. You can download it from Play Store. All right, and after downloading, just make your account and get the subscription, Iconic or Plus, whatever you want. And before that, if you want to attend, so then you can attend unlimited free classes as well. All right, there's no restriction in that, and you can watch unlimited YouTube videos also. We are taking live sessions on YouTube also, many channels. So this is a channel for English watching students, who wants to do their preparation in English. So like similarly, Hindi channels are also there. A lot of Hindi channels. In English there are a few, 1 or 2 channels. All right, so this was about everything on Unacademy. Now let's begin our practice session today. So first, let me tell you about the nth roots of unity. All right, quickly. So I'll tell you some points, and then we'll begin our session. So whenever you are solving this equation, x raised to n is equal to 1, how to solve it? It's a quick revision. So I'll tell you important points, and then we'll begin. All right. So first of all, whenever you are taking nth root of any number, just write that number in Euler's form. So it is e raised to iota and general argument is 2k pi, right? 2k pi, like this, and then take the nth root, so you get x raised to n is equal to e raised to iota 2k pi divided by n. All right, so these sorry, you have taken nth root, so remove this n. So these are the values, and for k is equal to, you just need to take k from 0, 1, 2 and so on up to n minus 1, and after that roots will start repeating. All right, so if you take n, you'll get the same value which you were getting for 0. If you take n plus 1, if you put k is equal to n plus 1, you'll get the same value which you will get for k is equal to 1. All right, so these are the roots. Let me plot these roots immediately. So these roots lie on a circle of unit radius. All right, and if you join all these points, then they form a polygon, right? N-sided regular polygon. So this is a circle. uh, See, this is your first point. For k is equal to 0, you'll get one root as 1, then other root will be e raised to iota 2 pi by n, we take it alpha. Then next root will be this, which is e raised to I 4 pi by n, and if you compare it with alpha, it is alpha square, right? If you can see square the first value, this you'll get the second one, right? Similarly, you'll keep getting alpha cube, so 6 pi by n and so on. So these are the roots I was talking about. Okay, they lie on the circle. All right, the last one. So if you join them, they form a polygon. They form n-sided regular polygon. All right, they always form n-sided regular polygon. All right, I hope it is clear. All right, so this is alpha cube, alpha raised to 4 and so on. This is alpha raised to n minus 1. So these are the roots, first thing. Now, two important equations about this. First equation is that alpha is the root of this equation, so alpha will satisfy this. So first very important point is that alpha raised to 1, n is equal to 1, okay, this point. And second important point is that sum of the roots is 0. So that is 1 plus alpha square and so on up to alpha raised to n minus 1, that is equal to 0. All right. So these are two very, very important equations, and using these two equations, you can answer a lot of questions. Okay. For example, let me tell you some important points. So what are these important points? First point is that if you put m power to all the roots and add them, okay, add them, then you get alpha raised to n minus 1 whole raised to m. So you get two values. First, 0, 0. When do you get 0? You get 0. This is a revision, so I am doing it quickly. You get 0 when m is not a multiple of n. M is not a multiple of n, right? But if m is a multiple of n, that means integral multiple, n or 2n or 3n, then you can see that all these numbers will become 1, all right? And all these numbers if become 1, then this sum will be nothing but 1 plus 1 plus 1 plus 1 n times, so it is going to be n, all right? So you get two answers. So suppose you are taking 11th root of unity and you are adding all the roots with by putting 12 power on all the roots, then this sum is going to be 0, all right? So GP, you can add them and use this relation, you'll get the answer, all right? But don't use the formula of GP when m is equal to ni, because in that case common ratio of the GP will be 1 and you can't use that formula. In that case all the terms will become 1, so you can directly add them, all right? So this is the first very important point. Now second important point is, if I write this root in sigma form, then this is alpha raised to r from 0 to k minus 1, all right? This is equal to, if I write this alpha raised to r or alpha raised to k, this is n minus 1, I'm sorry. So if you put Euler's form, it is e raised to iota 2r pi by n, all right, 2r pi by n, r from 0 to n. And then if you write in trigonometric form, it is going to be, let me write it here, sigma sine 2r pi by n cos, and simultaneously I'm distributing sigma also, cos theta plus I sin theta, so cos plus iota take common, and sigma of sine 2r pi by n, all right? So this is going to be 0. So now you can compare. This is your real part, this is your imaginary part. So real part is equal to 0, imaginary part. So you'll get two relations. Sigma of cos of 2 r pi by n r from 0 to n minus 1 is equal to 0. So this is a series of cos. You get this such series is a lot in lot of questions. And sigma sine 2 r pi by n. Okay, r from 0 to n, this is also 0. In this you can start from 1 also, because sine 0 is 0. So first term is already 0. So next you can start from 2. Right, so this part was 0. If it is not visible here, so this part is equal to 0. So using that, we have got these two results. So in this form also they ask questions. All right, so this is another important point. Now let me tell you next important point. So next important point is this, that if alpha x is equal to alpha is equal to e raised to I 2k 2 pi by n. All right, 2 pi by n, the first root apart from 1. Okay, first complex root, you can say first imaginary root, especially complex. The one is also complex. 2 pi by n. Okay, this is your alpha. So this is nth root of unity. So you can write this equation x raised to n minus 1 can be written as, so this is another way of writing this equation, x minus 1 into x raised to n minus 1 plus x raised to n minus 2 and so on up to x plus 1. All right, so in this way you can write this equation. Then alpha square, alpha cube and so on, alpha raised to n minus 1 are the roots of, if I leave 1, this 1, then these alpha to alpha raised to n minus 1 are the roots of this equation, right? Are the roots of this equation, x raised to n minus 1 plus x raised to n minus 2 and so on plus x plus 1. So whenever you see such equation like x raised to 10 plus x raised to 9 plus so on up to x plus 1 has root alpha, alpha square, alpha cube and so on up to alpha raised to 10. That means alpha is the 11th root of unity. All right, alpha is 11th root of unity. Let me give you the example. If I say if alpha is a root of x raised to 10 plus x raised to 9 plus so on up to x plus 1 is equal to 0, this implies that alpha is 11th root of unity. Okay, you can use this. That means you can take alpha is equal to e raised to iota 2 pi by 11. Okay, this is your alpha if it is not given directly. You can take this. I hope you are getting this point. Okay, so this point is again very important point. Then next important point is this. Again this equation x raised to n minus 1 can be written as, if you know the roots, if roots of this unity, roots of nth roots of unity are 1, alpha, alpha square and so on, alpha raised to n minus 1, then you can write this equation as x minus 1 into x minus alpha into x minus alpha square and so on up to x minus alpha raised to n minus 1. Okay, so you can factorize. Now here we factorize into two factors, one linear and another n minus 1th degree. And in this important point, we are factorizing this polynomial in nth degree polynomial in n factors. All right, because we know all n roots, so we can write all n factors. If alpha is a root, then x minus alpha is a factor. That is the factor theorem of polynomials, right? So using that factor theorem, we can factorize it. And this is very important expression. This is very important identity, you can say, equation or identity. This is very important identity because you are just factorizing one polynomial and equating it with the given polynomial. That means it's an identity. Left and right values will always be equal for all values of x. So we can put anything in this, like x is equal to 2, x is equal to 3, x is equal to 4. All right, and they can ask you, like for example, if they ask you the value a minus alpha into a minus alpha square, in this case up to a minus alpha raised to n minus 1. So what will it be? It is a raised to n minus 1 divided by this factor a minus 1, right? Yeah, provided a is not equal to 1. If a is equal to 1, then you need to take the limit of this. So that will be 1, n. If you take the limit, if a is approaching to 1, then you can take limit both hand sides, and limit of this is going to be what? Or you can put in this. All right, you can use this one. Equate this, x minus 1 will get cancelled. You can put 1 in this. Simple, as simple as this. All right, guys. So I hope this point is clear to everyone. So these are some very important points of polynomials. I mean, okay. Uh, hmm. So let's begin the session, and cube roots of unity will be included in this, and you can take nth root of any number. So let's begin with this. Let's just start our practice session. So basically it was a practice session, and that was a quick revision of this. And we'll do when we'll start geometry, then I'll again tell you important points of geometry, and we'll continue with practice session. So try this one. Try this sum for a minute, and then I'll discuss with you. All right, so let's solve it. Solve this session. So now in this case, we need to take cube root of iota. So how to take cube root of iota. So we can write iota as e raised to I pi by 2 plus 2k pi, right? And then take the cube root. So if you take the cube root, then cube root of it, this number is I. If you just simplify this, then it is going to be 4k plus 1 into pi by 2 and whole raised to 1 by 3, right? Whole raised to 1 by 3. Then you can use this is equal to e raised to iota 4k plus 1 into pi by 6, all right? And then put k is equal to 0, 1 and 2. So you'll get three values, and after that values will start repeating, okay? So you'll get three distinct values by putting k is equal to 0, 1 and 2. So let's put it. If you put 0, 1, 2, then first value will be e raised to iota pi by 6, all right? This is first value. So one option might be correct, or maybe two options are correct, or maybe three options are correct. We'll see that how many roots are given, because we are going to get three roots, okay? Cube roots. So if you put k is equal to 1, it is going to be e raised to iota. If you put k is equal to 1, it is going to be 5 pi by 6, 5 pi by 6. And then you put k is equal to 2, so it is going to be 9 pi by, so e raised to iota 9 pi by 6, all right? So these are the values. If I expand it, it is cos pi by 6 plus iota sin pi by 6. So cos pi by 6 is root 3 by 2 plus iota by 2. So this is one of the value. You can see first option is correct. All right. So this is A option. Then you can see if you put 5 pi by 6. So what is the value of 5 pi by 6? Cos 5 pi by 6. Okay. So cos 5 pi by 6 is cos pi minus pi by 6, and that is minus cos pi by 6. So it is going to be minus root 3 by 2, and sin pi by 6 is plus 1 by 2. So it is iota by 2. So minus root 3 by 2 plus iota by 2 is not there in any of the options. So although this is a root, but it is not given in the option. All right. So A option is still correct. And then 9 pi by 6. 9 pi by 6 is 3 pi by 2. All right. So if you take 3 pi by 2, then cos 3 pi by 2 is going to be 0 plus iota sine 3 pi by 2. So what is sine 3 pi by 2? It is minus 1. So this is 3 pi by 2. All right. So 3 pi by 2 is minus 1. So that is minus 1. So one root will be minus iota. All right. So if you can see, if you cube minus iota, if you do the cubing of this, you'll get plus iota. Cube of minus iota is plus iota, right? So this minus iota is a cube root of iota. Are you getting this point? So only A option is given. So we are getting 3 roots. Let me circle these 3 roots. This is second root, and this is third root, and this is the first root. Even if you plot these roots, they will lie on an equilateral triangle. All right, on an equilateral triangle. And obviously circle, as I told you, they will lie on a circle of unit radius, because modulus of iota is 1. So they will lie on a circle of unit radius. But the first root will start from pi by 6. So this is your first root. Okay. So this angle is pi by 6. Second root is 5 pi by 6. So that is this angle. If you add 120 in this, you'll get this second root. And third root, you're getting this. All right. This. So you can see this angle is 120, this angle is also 120, and this angle is also 120, 120, 120, 120, right? And if you join them, they will form an equilateral triangle, right? They will always form a regular polygon. So these are 3 roots, okay? So this first root is given in the option, so we'll take it. I mean, that will be the correct option. So this first is the correct option. Now let's move to our next question. So this is our next question. Try to solve it. I have already told you all the important points related to complex numbers, nth roots of unity. So you try this one. Thank you, Anil. So in this, cis means e raised to iota 2 pi by 7. So you can figure it out. Okay, who's, what is the value of n? Right. Okay, so by looking at this alpha, let me solve it. So by looking at this value, alpha is equal to e raised to iota 2 pi by 7. Okay, you can answer that this is 7th root of unity. If it is 7th root of unity, then you can write alpha raised to 7 is equal to 1, right? If it is 7th root of unity, then alpha raised to 7 will be 1. Then you need to form a quadratic whose roots are given in terms of alpha, right? So to form a quadratic, you need sum of the roots and product of the roots. So you need beta plus gamma. So first you find beta plus gamma. So beta plus gamma is nothing but alpha plus alpha square plus alpha raised to 4 plus alpha cube plus alpha raised to 5 plus alpha raised to 6. Okay, so it is going to be alpha plus alpha square plus alpha cube plus alpha raised to 4 plus alpha raised to 5 plus alpha raised to 6. So that is going to be minus 1. All right, how did I do that? Because I know if 7th root of unity 1 plus alpha square up to alpha raised to 6 is equal to 0. Sum of all the roots is 0. So sum of these 6 roots will be minus 1, right? So alpha, we have got alpha plus beta. Now let's find alpha into beta. So alpha into beta, product of the roots. Sorry, it is beta into gamma. All right. So I was taking alpha, beta into gamma. Okay. So the quadratic whose roots, the quadratic which we need to form have roots beta and gamma. So we're finding sum of the roots of that quadratic and product of the roots. All right. The sum we have already got. Now let's solve for product. It is alpha plus alpha square plus alpha raised to 4 multiplied with alpha cube plus alpha raised to 5 plus alpha raised to 6. All right. And then if you open it, you'll get alpha raised to 4 plus alpha raised to 5 plus alpha raised to 7, which is 1 actually. Then alpha raised to any power which you get beyond 7, you can use this formula alpha raised to 7. Like if you're getting alpha raised to 8, you can write it alpha. If you're getting alpha raised to 10, you can write alpha raised to 7 into alpha cube. Alpha raised to 7 will become 1 and alpha raised to 3 will be remaining. So any power which is more than 7, do not worry about that. You can always reduce it to 1 to 6. All right, 1 to 6. So you have got alpha raised to 7. Now multiply. So total 9 terms you are going to get. All right. So there's alpha raised to 6 again plus alpha raised to 7 again plus alpha raised to 9 again plus now it is going to be alpha raised to 7 again plus alpha raised to 8 again plus alpha raised to 10 again, right? Now alpha raised to 7, alpha raised to 7, alpha raised to 7 is 1, 1, 1. So 3 plus. Now let's write it. Alpha raised to 4 as it is. Alpha raised to 5 as it is. All right. So done, done, done. Alpha raised to 6 as it is. All right. This is alpha raised to 9, which you can write alpha raised to 3. Sorry, alpha raised to 2, I'm sorry. Because alpha raised to 9 is alpha squared into alpha raised to 7, right? So it is going to be alpha square, all right? Plus, this is alpha raised to 8. So alpha raised to 8 is going to be alpha only. And alpha raised to 10 is going to be alpha cube only. Now you can see this is sum of all the 6 roots, which is minus 1 again. So 3 minus 1 is it is going to be 2, right? So 2. So you've got sum of the roots and product of the roots. Now let's form the quadratic. So quadratic is x square minus sum of the roots. So beta plus gamma into x plus product of the roots. Product of the roots is beta into gamma. And we have got all two values. So put the values. It is going to be x square minus beta plus gamma is minus 1. So it is minus 1 into x plus beta into gamma. So 2 is equal to 0. So the answer is x square plus x plus 2 is equal to 0. This is the quadratic which has roots as given in the question, this and this. All right. So see, now in place of x, obviously you can use y, z, and whatever name of the variable you want to use. All right. So that's not a problem. You can read this as z square plus z and plus 2. All right. So z square plus z plus 2 is C is the correct option. All right. So I hope you have got it. Now let's do the next problem. So here it is, the next problem. Again, it's based on cube roots. So try to figure it out. Then I'll tell you one of the very good method to solve it. So I'll wait, I'll discuss in a minute, and this is based on cube roots of unity. So it's a shifted, but the triangle will be shifted because you have z plus ab. All right. But if you see it geometrically, then there won't be any effect on the area. Area will remain same, lengths will remain same, even if we shift the triangle on which cube roots of unity lie. Hello Subhash, you are getting B, all right. Let's discuss it in a minute. Hi Harshita, how are you? Try this sum. Write in the comment box if you're getting any answer. All right, then let me solve it. You are also getting B. All right, Harshita is also getting B. So let me check. See, first of all, whenever you have this equation x cube is equal to 1, you have three roots. X is equal to 1, omega and omega square. I suppose you know this because it's a practice session, so revision or practice session. So obviously you know about the cube roots of unity. But let me remind you, if you have x is equal to a, then a cube actually, then you'll get x is equal to a and then a omega and then a omega square as the roots. All right. And if you have x minus 1 whole cube, suppose x minus 1 or x minus b or x minus k, if you take whole cube is equal to a cube, then your roots are going to be, now k will be added to all the roots. So k plus a and k plus a omega and k plus a omega square. So if k is a real number, then all three roots will shift towards right side, all right, translate you can say. And if k is a complex number like x plus iy, then the roots will shift towards right by x units and up y units, right, if x and y are positive. So that shifting will be there if you add k to all the roots. So that is what we need to do. See, I'll tell you, z plus ab is equal to, we are going to get a, then a omega and then a omega square. All right, these are the three roots. Now what will be the values of z values of z are going to be a minus a omega ab, sorry, and a omega minus ab and a omega square minus ab. All right, so these are going to be the roots. But suppose you need to plot, I'll tell you what is happening here. You can figure it out easily. Let's assume a positive. All right, you can take a negative also, that doesn't matter, it won't affect our answer. I'll tell you how. So first root is going to be a. Suppose AB is not there. Let's take AB 0. All right. If you take AB 0, your first root is going to be a. Then second root is going to be a omega. This is going to be a omega. And third root is going to be a omega square. All right. So a omega square. And you will form the triangle like this. So this will be your equilateral triangle whose side length is required. All right. Yeah, this is an equilateral triangle. This is 60 degree, this is also 60 degree, and this is also 60 degree. Diagram, let me correct the diagram. This is your y-axis. All right. See what is going to happen when you add or subtract some constant. So let's take AB negative. So these roots will translate towards right. If AB is positive, these roots will translate towards left. And if AB is a complex number, I'm taking minus AB as x1 plus iota y1. Even if you can take complex number, then what will happen? Then these roots will translate, a will translate x by x1 units towards right and by y1 units towards up. So this a will come here. This is going to be your a plus minus ab. All right. And this root similarly will translate right and up. So it will come somewhere here. Okay. Let me choose some other place. Okay, so A is translating towards right and up by y1 unit, and right side towards right side by x1 unit. And similarly E omega will be here and up, so this place, and A omega is right and up, so like this place. Okay, so a triangle is going to be like this. Now see, all three roots are translated by x1 and y1 units towards right and up or down, doesn't matter. Do you think that this side length or area of the triangle has changed by translation? No, side length will remain same, right? So side length will remain same. That means there's no effect on the side length by adding this number to Z, AB. All right, there's no effect. That means just find the side of this triangle, which you can find easily. Join this with the origin, all right, and join this with the origin. So this is your mod of A, right? This length is your mod of A. This length is also mod of A, and drop a perpendicular. So you can use this triangle, all right. So this angle is 60 degree, this angle is 60 degree, all right, this angle is 60 degree, because total is 120. You can find this length, which is half of the side length, and double it, all right. So this mod of A, this angle is right angle, all right. This OA is hypotenuse, so OA cos theta, okay. So a side length, basically AB, let's say AB is the side length of the triangle. So AB is equal to twice of OA cos 60, all right. So what is cos 60 is root 3 by 2, all right. So what is OA? OA is mod of A into 2 into root 3 by 2. So what is your answer? B. Yes, you guys were getting it right. Well done, Harshada and Subhash. Yes, you got it right. Very nice. Okay, so this is the way to solve it. They can make this equation complicated, but you can shift it to origin, and by taking origin as the center you can solve it always if it is a regular polygon. All right, I hope you have got it. Now let's move to our next problem. Okay, so this is our next problem. I've told you in the beginning about this polynomial, that what does this indicate? Z raised to 6 plus Z raised to 5 and so on up to 1. And Z1, Z2, Z3, Z4, Z5, Z6 are given as the roots of this equation. We need to find the value of an expression which is written in terms of addition of Z1 and product of Zi. So try to solve it. Find the value. If you it's a numerical value, so if you're getting any value, let me know. Write in the comment box. Okay, Subhash is getting 4. You're getting 4, Subhash. All right. So you're done. Any other answers? All right, then let me check it. See, first of all, what I have told you, the beginning only, that this is the equation x raised to n minus 1 is equal to x minus 1, x raised to n minus 1 plus x raised to n minus 2 and so on up to x plus 1. All right. So if roots are 1, alpha, alpha square and so on, alpha raised to n minus 1, then 1 is the root of this factor and these n minus 1 roots are the roots of this equation, right? So if alpha is given as the root of this equation, then you can say alpha is the root of x raised to n minus 1. That means nth root of unity, right? So using that, you can write z raised to 7 minus 1 is equal to z raised to 7 minus 1 is equal to z minus 1 into z minus alpha and so on up to z minus alpha raised, oh, I'm sorry, not in this way. This is another way of writing it. Just use this z raised to 6 plus z raised to 5 and so on up to z plus 1. So roots of this are going to be alpha, alpha square, alpha cube and so on alpha raised to 6. The alpha is 7th root of unity, e raised to iota 2 pi by 7. So this is your z1. He has said z1, z2, z3. So z1 is nothing but alpha, z2 is nothing but alpha square, z3 is nothing but alpha cube, and z6 is nothing but alpha raised to 6. So the first very important thing which you need to write is this. What? So I told you important points that if alpha is 7th root of unity, then alpha raised to 7 is 1. First thing. Second thing is that 1 plus alpha square and so on up to alpha raised to 6 is going to be 0. Third important thing, that 1 plus alpha raised to m plus alpha square raised to m and so on up to alpha raised to 6m. I have told you this in the beginning. This has two answers. 0 if m is not a multiple of 7, 7k type, and 7 if m is a multiple of 7k type, right? So this, let's see, we need to use all these equations in this question. So what is this first expression? I'm writing this first one by one. Let's solve these three expressions. So it is I from 1 to 6 zi raised to 5. That means just take zi, 1 minute. First take z1 is equal, z is equal to alpha, all right? So this is nothing but alpha raised to 5 plus alpha square raised to 5 plus alpha cube raised to 5, all right? But 5 is not a multiple of 7, right? See, I have written it here, right? If it is a multiple of 7, then answer will be 0, and if it's not a multiple of 5, then answer will be 0. And alpha raised to 6 raised to 5. But see, 1 is not there, right? So value of this will be 0 minus 1, 0 minus 1, because this complete value is 0, right? If m is not a multiple of 7. So it is going to be minus 1. So this first value is going to be minus 1. I hope it is clear. Now let's solve this second one. So this is zi raised to 14. Okay, now you're putting a power which is a multiple of 7, right? Here it was not a multiple of 7, now it is a multiple of 7. But remember, you have only 6 terms, not all 7, all right? So value will not be 7, it will be 6 because 1 is missing, all right? So I from 1 to 6, it is going to be alpha raised to 14 plus alpha square raised to 14 and so on up to alpha 6 raised to 14. So you have 6 terms and all these terms will become 1. So 1 plus 1 plus 1, 6 times is 6. I hope it is clear. Now the last term, it is product. So last term is pi product zi I from 1 to 6. I from 1 to 6. So it is going to be your alpha into alpha square into alpha cube and so on, alpha raised to 6, which you can write alpha raised to 1 plus 2 plus 3 plus 4 plus 5 plus 6, all right? So you can add these numbers. So it is going to be 6 into 5, 6 into 7 by 2, so 21, right? 21, yeah, 21. So alpha raised to 21, and what is this alpha raised to 21? 21 is a multiple of 7, so it is going to be 1, all right? So now put the values. So this given expression is equal to what? What is the answer? So it is now -1. This is 6 and this is 1. So yes, answer is going to be 4. Somebody has given the answer 4. So yes, Subhash, very nice. The answer is 4. Harshita, it's not 6, it's 4. All right. All right, so now let's continue. I hope it is clear. Then continue with this next problem. Solve it. This is a very good question. Although it's based on Euler's form, it's based on Euler's form. No need to do much about it. I mean, it's looking complicated, but it's not actually. Just use the Euler's form and you can simplify it easily. Let me tell you that you can take AK as e raised to iota k pi by 20 e raised to I theta. This is your AK. Try to put this in the given expression and simplify. You will get something. That is the main part. Oh, Ashita, you have given your answer 3. Confidence, this time it is going to be correct. All right, let's see. We'll check it. I'm not telling you the answer now. I'll solve it and then I'll tell you what is the answer, if it is correct or not. Let others try. Subhash is also solving. Let him solve. All right, then let me solve. Okay, I've got the answer of Subhash also. It is A. He's also getting 3. All right, so both of you are getting 3. Let me check then. See, AK is given and you need AK plus 1 minus AK. So let's do it here only. AK plus 1 minus AK. All right, and we need to take mod also. So AK plus 1 minus AK is e raised to I. If I take this as alpha raised to k, it will be easy. What is your alpha? Your alpha is nothing but e raised to I pi by 20. All right. So I don't need to write e raised to I k again and again. Okay. So it will be simple by taking ak as alpha raised to k. So ak plus 1, and mod of what is mod of alpha? Mod of alpha is 1, right? Mod of e raised to I theta is 1, so we'll use that. So it is alpha raised to k plus 1 minus alpha raised to k. So you take alpha common, so it is going to be mod of alpha into mod of, in fact, mod of alpha raised to k common. So it is going to be alpha minus 1, and mod of alpha raised to k will be 1, right? Mod of alpha is 1, so mod of alpha raised to k will also be 1, and it is mod of alpha minus 1. Ishwar, you have written something. Have you given the answer? Why have you deleted it? So mod of alpha minus 1, all right. Then similarly, you can find alpha 2k plus 1, a 2k plus 1, a 2k plus 1 minus a 2k plus 2, all right, mod. Then it is going to be alpha raised to 2k plus 1 minus alpha raised to 2k plus 2. You can see what is common in this. Alpha raised to 2k plus 1 will be common with mod, and what is remaining inside? 1 minus alpha, which is same as alpha minus 1. So this is also 1, so it is going to be alpha minus 1 mod. So alpha is a constant basically. With respect to k, alpha is a constant. Alpha minus 1 mod is a constant. So what is this written in sigma? Sigma, it is written k from 0 to 2018 mod of alpha minus 1 divided by sigma k from 1 to 673 mod of alpha minus 1, all right. Then you can take mod of alpha minus 1 as a constant, so it will come out. So mod of alpha minus 1, it is sigma 1 only, and in denominator also mod of alpha minus 1 will come out, and it is sigma 1 only, right? This will get cancelled, and what is sigma 1? 1 we are adding how many times? From 0 to 2018. 0 to 2018, how many numbers, how many terms are there? 2019, so it is going to be 2019, all right. And 126, so yeah, 12673, it is 673 only, right? So it is going to be 673. Try to cancel it. Can you cancel it? Yes, it is actually 3 times, so you guys are getting correct answer. 3 is the correct answer. Well done, well done guys. Very nice. I'm very happy you could do it. So very good point. It was scary, but it was not that difficult, but it is looking scary, right? It was so simple to solve it. Just take e raised to iota pi by 20 as alpha and ak as alpha raised to k, and it's done. All right. No more calculation, not lengthy, not too much of calculation. All right, so now solve this one first. Okay, this is related to geometry, so I'll do it later. We'll do it later. First, do this one. This is again a good problem of nth roots of unity. So try this. So if you have seen how to solve this problem, then perhaps you'll be able to do it. It's an easy problem. Just one trick you must know. I mean, it's not a trick, the way of doing such problems, okay, how to get this expression, but certainly you need to use this, okay. This is another form which I've told you in the beginning, because nth roots of unity, then x raised to n minus 1 can be written as x minus 1 into x minus z1 into x minus z2, all right. So 1 and so on up to x minus zn minus 1. You need to use this uh, way of factorizing, okay. I mean, this way of expressing the polynomial, all right, factorized form, you need to use it. So try this one, try to get the answer, see if you're getting any answer. That's a very good problem. Solve it. I'm coming back in a minute. Let me check my sound as well. If it is coming. Harendra Gupta, you're not getting. Okay, I'll solve it. I'll solve it. Uh, Let me solve it then. And meanwhile, if you get any answer, then write in the comment box. See, whenever you have such equation, uh, you should take log first and then differentiate, because if you take log, these terms which are in product will come in addition, right? First thing, and then you differentiate. Then differentiation of log is basically 1 upon x. Log x is 1 upon x, so we'll get these factors in denominator as well, and then we can put x is equal to anything. All right, so first thing is take log. So log x raised to n minus 1 is going to be log of x minus 1 plus log of x minus z1 plus log of x minus z2 and so on up to log of x minus zn minus 1. All right, this is the first step. I think it is clear. Subhash is getting it. All right, let's check. Then you differentiate it and then put x is equal to the desired number, which you need to get. I mean, whatever the number is written in place of x in the given expression. So differentiate it. Differentiating this will get 1 upon x raised to n minus 1 into differentiation of x raised to n, that is n x raised to n minus 1. All right, this is the differentiation of left hand side expression, and differentiation of these expressions are x minus 1 plus 1 upon x minus z1 and then plus 1 upon x minus z2 and so on plus 1 upon x minus zn minus 1. All right, this is what you're getting. I hope it is clear. Yeah, then what to do? Then you put x is equal to what? X is equal to 3. If you put x is equal to 3 in this expression, you'll get the desired result, right? This is what is required, right? So put x is equal to 3 and you get the answer. Put x is equal to 3. So that means A is not the correct answer. Yeah. So A is not the correct answer. You got in the trap, Subhash. Probably you thought you are doing some mistake, but actually answer is uh, this minus 1 divided by 3 raised to n minus 1 minus 1 by 2. All right. This is the answer. So answer is D option actually. None of these. None of these is the correct answer in this case. All right. So A is not the answer. I hope it is clear. Okay, so now solve it. Now solve this another problem. Thank you, Arendra. This is again a very good problem. Solve it. It's a numerical base, so single digit numerical answers. You can write in the comment box whatever the value you're getting of D. Write this series which is given on the left hand side in form of sigma. Write the rth term of sigma and try to simplify it. And also decode what is this T. That is an important point. That is a very, very important point. Yes, Haren, very true. T is omega square. Yes, T is omega square. So this Haren has already given us this hint that T is nothing but omega square. So use it. It's a cube root of unity. Getting anything, guys? All right, Subhash and Harshita, you guys are getting uh, one. Okay. All right. Already we are getting the answer. So, all right, I will start solving it. Meanwhile, if others are getting any answer and what's his name? Harendra, if you are getting any answer, then type it comment box. Okay. See what to do. 1 minute. First of all, you need to write the general term. So sigma of, I'm writing this series, which is given on the left hand side in form of sigma. So you can see it is 2 into, it is 2 into 1 plus t, 1 plus t square, 3 into this. And so if you're going to write the rth term, what is this going to be, rth term? So 2 you can write 1 plus 1, 1 plus 2, 1 plus 3 like that only. I mean 2, 3 can be written as 2 plus 1. 3 can be written as 4 can be written as 3 plus 1, like in this it is. So using this you can write the general term easily, right? So in place of n just put r. Yeah, the last term is given, then you can write the general term. So r plus 1, it is r plus t, and it is r plus t square. All right. So now this is going to be r plus 1, and you know what is this, all right? This is t is nothing but omega and omega square. So this is going to be r plus omega square, and r plus omega raised to 4 is r plus omega, right? Omega raised to 4 is omega. Now open it, and this is going to be r plus 1 into r square plus omega square. By the way, you can write directly, but if you don't know, then you can just multiply, put the values. Omega plus omega square is minus 1, omega cube is 1, so it is going to be r plus 1, and it is r square minus 1 plus 1. All right, then sigma of this is what, r cube plus 1, a cube plus b cube is a plus b, and then a square plus b square minus ab. So a cube plus b cube, that is r plus 1. So sigma of r cube plus sigma of 1, this is what you're getting, r from 1 to n. So you'll get a polynomial, fourth degree polynomial, because sigma r cube is fourth degree polynomial in n, right? So just put the value and add it. So it is going to be n into n plus 1 by 2 the whole square. So I'll write it 1 by 4 outside, plus this is going to be n. All right. So in this first, what do you need? You need coefficient of n. So this you can see is going to be a fourth degree polynomial, the first term. In this you are not going to get n. Why? Because you can see n square is written outside. So this is the only term of n. All right. So what is the coefficient of n? Coefficient of n is equal to 1. All right. So yes, whose answer was 1? Uh, Somebody has given the answer 1. Subhash and Ashita both. Okay. Yes, you guys have given the right answer and so you have written something. Sigma r cube. Yes, it is sigma r cube, but plus 1 also. All right, sigma r cube plus 1. I hope you have done that. All right, so now let's move to another problem. This is a very easy problem. Very easy. Solve it. This is another form, another way of writing. This is, what is this? Solve it, solve it. Do it fast. S आ रहा है 48 minus 48 iota. 48 minus 48 iota. No, 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 Harendra, no, no. How did you get 48? 48? No. Let me solve it for you. So actually, I've told you this, that sigma of sine 2k pi divided by n, if k starts from 0 to n minus 1, it is 0. This is the sum of all the imaginary parts, of nth roots of unity, and sigma of cos 2k pi by n, k from 0 to n minus 1 is also 0. This is sum of all the real parts of nth roots of unity. All right. So because sum of all the roots is 0, so sum of their real parts as well as sum of their imaginary parts will be 0 individually, right? So we need to use this. In this you are using 11th root of unity. All right. So if you're using this sigma, I can write sine 2k pi using this relation divided by 11. If k starts from 0 to 10, okay, this is going to be 0, but in this you need k from 1, but it doesn't affect because for k is equal to 0, first term is already 0. If you put k is equal to 0, sine 0 is 0, so you can start from 1 also. The result won't change. All right, so first value is 0 only. Now what is this second one? Second is, let's find sigma of cos 2k pi also. 2k pi divided by 11. If you start from 0 to 10, it is going to be 0, but you are starting from 1, right? So if you start from 1, then first term is missing. You can write like this. If you put 0 in this, that term separate that term, so that is cos 0 plus, you can write sigma of cos of 2k pi by 11. K starts from 1 to 10. This is what is required, right? So value of this is going to be minus cos 0. Minus cos 0 is minus 1. So sigma of cos 2k pi by 11, k from 1 to what, 10, is going to be minus 1. Okay, so let's put these values here. We need sigma of sine 2k pi by 11, k from 1 to 10, minus iota times, distribute this sigma. I am distributing sigma of cos 2k pi by 11, k from 0 to 10. All right, so put the values. This first value is 0 and the second value is -1. So it is going to be 0 minus iota into -1, so it is going to be iota only. So s is nothing but iota. So s is nothing but iota. So s plus s bar is iota minus iota. Iota bar is minus iota, so that is 0. So first option is correct. This s into s bar is basically iota into minus iota, so it is going to be iota square, so it is +1. So yes, this option is also correct. B option is also correct. All right. Then this C option, I think this is missing. What was it? So I think it is 1 by root 2 or 1 by root 3. Whatever it is, if it is 1 by root 2 or 1 by root 3, but that is not the root of iota. Okay, we did it. Root of iota is not going to be 1 by root 2, because if you multiply 1 by root 2 two times, it is not going to be iota. So all right, let's ignore it. And then s minus s bar is not 0, because s plus s bar is 0. So A and B are the correct options. Okay, what we can see. So I hope it is clear now. Any doubts? Any doubts? Let me know. Got it, Harind? All right. Then let's move to our next problem. All right. Try this one. This is again a similar one. Wait a minute. Let's solve this one, okay? That was a similar problem. So we are solving this now. So today I have a long sessions. Yeah, I'll cover this complex numbers for 1 more hour, and then after that I'll start geometry, arithmetic or geometric progression. It's a regular session, and in the evening 6 p.m. I'll be taking a lot of binomial coefficients, series of binomial coefficients today only. So it's a YouTube day today of Unacademy. Getting any answer, guys? All right. Okay, Harshida is getting 7. Okay, so what is this question? Let me decode. So S is the set of all the complex numbers Z satisfying this. Okay. So basically, if you write this, then we have already done it twice today. So Z raised to 24 minus 1 can be written as Z minus 1 into Z raised to 23 plus Z raised to 22 and so on up to plus Z plus 1. All right. So these are 24th roots of unity. So S is the set of complex numbers satisfying this. Number of elements S in capital S. The number of elements S. Okay, so how many numbers will satisfy this equation? So 24 numbers will satisfy. It's a very straightforward question. So this small s is nothing but, which is actually number of elements that satisfy this equation. So that is 24 roots because it's a 24th degree equation. So all the roots complex and real. Okay, real is only one. Sorry, might be more than one, but all roots, real or imaginary. So all roots are called complex numbers. So we have 24 roots of this equation. Then we need to find, so what you need to find the positive divisors of s raised to 6. Okay, so before doing s raised to 6, just prime factorize this number 24, write as a product of prime numbers. So 24 can be written as 2 cube into 3. All right, then you can write s raised to 6. So it is going to be 2 raised to 18 into 3 raised to 6. Okay, and what you need, what, wait a minute, oh, I'm sorry, is that something, so I missed something, some information. No, s is not 24. S is those elements, those number of those elements such that s raised to 6 is p real. All right, that is the question. So it makes the question very good. So s, so we know that alpha raised to 24 is 1, right? So 1, or alpha raised to how many roots will be real? Okay, if we put 6 power, that we need to check. All right, so actually the general, if general root, if I write as alpha is equal to e raised to I 2k pi by 24. All right, this is the way. So alpha raised to 6, let's write alpha raised to 6. So alpha raised to 6 will be e raised to I 12k pi by 24, and this is going to be e raised to I k pi by 2. Okay, so e raised to iota pi or e raised to iota minus pi, these numbers are real numbers. Okay, you have k from 0, 1, 2, 3 and so on up to 23. So if it becomes an integral multiple of pi, if this number becomes an integral 2k, n pi, all right, n pi, let's write n pi iota, then it's a real number. So how to make it integral multiple of pi? By taking k is equal to even number. So yeah, so now we have got that k must be an even number. Okay, even number means k is equal to 0, 2, 4 and up to which number? Up to 22. 22 is the last value of k, even value. So how many values? Total you have 24 values, half of the values are even and half of the values are, so total 12 values, right? Total 12 values. Okay, so for total 12 values, and let me write those alpha also. That means alpha raised to 0, which is 1, alpha raised to 2, alpha raised to 4 and so on, alpha raised to what, 22. If you put 6 power on these numbers, they will become real. All right, so now we have got s is nothing but 12, s is 12, and 12 is nothing but what, 3 into 2 is square. Now you need s raised to 6, so s raised to 6 is 3 raised to 6 into 2 raised to 12. All right, this is what you're getting, s raised to, no. Number of divisors of s. Again, I'm getting confused. S raised to 6. No, this is just s. S is this. Now, what you need? Such that s raised to 6 is p. All right, this number is given P. This 12 is nothing but P. Total number of values, this is of P. The number of positive divisors of 10P, okay, that is the question. So 10P is what? 2 cube into 3 into 5, all right. So number of positive divisors of this number is number of positive divisors is equal to 3 plus 1, 1 plus 1 and 1 plus 1. So that is 2 into 2 into 4. How much? 16. Then you need sum of the digits. The sum of the digits of this is nothing but 7. So 7 is the answer. So final answer is 7. Oh, you got it right, Arshada. 7 is the right answer. Wow. Very nice. Okay, I'll explain it again. So he was saying that S, the number of elements of this, all the roots, all the root of all the roots are making a set capital S. In all the elements of this capital S, such that S raised to 6 is real. So I have written the general element alpha, the first root, e raised to I 2k pi by 12, right? 2k pi by 24 because that's 24th root. And I have written alpha raised to 6 because alpha raised to 6 we need to make real. So I'm getting it is e raised to I k pi by 2. Now this k pi by 2 should be an integral multiple of pi. That means k must be an even number, because whenever you have e raised to integral multiple of pi into iota, that becomes a real number, either plus 1 or minus 1, all right? Both are included. So to make this real, k must be these numbers, sorry, k must be these numbers, even numbers. So how many even numbers will be there? 12 values, because 12 even numbers are there and 12 odd numbers are there. So whenever alpha raised to even number will come, it will become a real number, all right? So in that way, you can say half of the roots, when you are calculating 12th roots of unity, then half of the roots by putting 6 power will become real, all right? So this number s raised to 6, how many s raised to 6 are real, is given equal to p. So we have got p is equal to 12, and 12 is basically 3 into 2 square. And then you can write 10p. So 10p is 3 cube into 3 into 5, 2 cube into 3 into 5. And the number of divisors of 10p, so that is divisors. I have applied the formula of divisors. This plus 1, this plus 1, this plus 1, p1 plus 1 into p2 plus 1. I hope you know that formula. So there's 16 and 16. You need the sum of the digits of this number. So there's 6 plus 1, 7. All right. This was the problem. I hope it is clear. Now let's move to another one. Now this is our next problem, again based on fifth roots of unity. It's a multiple correct type, so more than one option might be correct. So multiple correct type. Anashda is getting AB. All right. So alpha is the fifth root of unity. That means you can take alpha is equal to e raised to I 2 pi by 5. Remember that. So, all right, Subhash is getting ABC. All right, ABC. Arshita, you check. Have you checked C and D options? They are similar. You need to check at least one. All right. So first, in very, let me solve it. If you meanwhile, if you get any other answer, then let me know. See, first of all, sub alpha is one. Alpha is the fifth root of unity, so alpha is equal to e raised to I 2 pi by 5. Second is alpha raised to 5 is 1, and third is 1 plus alpha square plus alpha cube plus alpha raised to 4 is equal to 0. So first is very straightforward. First, obviously, mod of 1 plus alpha square, so mod will also be 0, and then you need to take mod of this 1 plus alpha square plus alpha cube. Okay, so write this is equal to minus alpha raised to 4, and then take mod. So if you take mod, it is nothing but mod of alpha raised to 4, and yes, it is 1. So B option is also correct, A is correct, A option is correct, and B option is correct. Now let's see C option. So for C option you need 1 plus alpha square. So you can write this in terms of alpha raised to 3 minus alpha raised to 3, and you need to take mod also, and minus alpha raised to 4. All right, take mod, because if you take mod, now you have only two terms. Okay, so take alpha cube common, so minus alpha cube take common, and mod of this, and 1 plus alpha will be remaining. This will become 1 again, because mod of whether you write alpha cube or alpha raised to 4, it is going to be 1 only. So there is 1, so you have got 1 plus alpha. So basically now you can see C and D options are same. Just check one of the C or D might be correct. All right, so how to check it? We need in terms of cos. Okay, so write this value. Okay, this, what is this value? 1 plus this is cos. Okay, I'm taking this angle as 2 theta. All right, this angle is 2 theta. 2 theta is 2 pi by 5, so theta is pi by 5. Remember that. So cos 2 theta plus I sine 2 theta mod. Now apply the formula. So 1 plus cos 2 theta is 2, cos is square theta by 2, so theta by 2 is theta, plus iota 2 sine theta cos theta mod. Now you can take 2 cos theta common, and remaining it will be cos theta plus I sine theta, right? And this is going to be 1, and 2 mod. Okay, this will come out with mod. So 2 cos. Now what is theta? Theta is pi by 5. So because cos pi by 5 is positive, so you can remove mod. So yes, C option is correct. So Subhash, your answers were correct. Absolutely correct. A and B were very easy to prove, and B is, there's some, you need to do some work in option C. And that too, it's not difficult. It's not lengthy, all right? It's a very simple calculation. Okay? Very nice problem. Not lengthy, conceptual, and easy also. I mean, easy to moderate. All right, again a problem. Now you have fifth and fourth roots of fifth and fourth roots, alpha and beta. They are fifth and fourth respectively, and then you need to find the value of one of the expression. Solve it. Okay, it's okay. Got it, got it. Okay. So alpha is the fifth root of fifth and fourth roots of unity, then value of this. So fourth root and fifth root, write the conditions. Alpha is the fifth root, so alpha raised to 5, write the relations immediately. Alpha raised to 5 is equal to 1, and 1 plus alpha square plus alpha cube plus alpha raised to 4 is going to be 0. Similarly, beta raised to 4 is equal to 1, and 1 plus beta square plus beta raised to what, 3, yeah, is equal to 0. Now let's simplify it. So 1 plus alpha, uh, 1 plus alpha square, oh, I'm sorry, so write all the factors of alpha together. 1 plus, what am I doing? Okay, so 1 plus alpha square, 1 plus alpha raised to 4, all right, then 1 plus beta, and 1 plus beta square, and then 1 plus beta raised to 4 is 1, so actually it is 1 plus, okay, I'm writing it, then I'll write the value, next step. Okay, so you can expand it, and but before that expand it, because this has less number of terms, or you can do this also simultaneously. So 1 plus alpha, 1 plus alpha square, 1 plus alpha raised to 4. If you expand it, you'll get something like this, right? So you can simplify it. So it is going to be 1 plus beta cube, and then beta square also, yeah, and then there is 2, and this actually is 0, right? So no need to calculate anything, it's 0 now, so 0. So you're getting 1 plus beta square plus beta cube, and that is 0, so answer is 0. It was easy problem, right? It was looking like you might think, okay, it's in this problem fourth roots and fifth roots, both the roots are involved, and what will be the answer? But actually it was easy problem. We have done such problems, so let me tell you about one, before doing next problem, let me tell you about one important series, and that series is actually series of cos and sine in product, all right? I mean, terms angles will be in AP, and then terms of cos will be in product. So it's product series of cos we got from complex numbers. How? When you have x raised to n minus 1, and then you write x minus 1 into x minus alpha into x minus alpha square, and so on, x minus alpha raised to n minus 1, where alpha is nothing but e raised to I 2k pi by n, all right? Remember that alpha raised to k, alpha is 2k pi 2 pi by n. So using this, if you put 1 in this, okay, 1 and minus 1, you can get series of cos and sine respectively. So if I put x is equal to 1, then you can cancel this. First of all, you need to take the limit. This is x minus 1. You can cancel x minus 1 if x is not 1, all right? And in fact, you can write x minus alpha into x minus alpha square, and so on up to x minus alpha raised to n minus 1 as x raised to n minus 1, x raised to n minus 2, and so on, right? Use that polynomial also, or get the limit. So when x approaches to 1, you put limit in this, and x approaching to 1 in this also. Then you get n left hand side, and 1 minus alpha, 1 minus alpha square, and so on up to 1 minus alpha raised to n minus 1. Okay, if I write the general term pi, okay, pi 1 minus alpha raised to k, all right, k from 1 to n minus 1, okay, and then this, what is this going to be? Now let's simplify in terms of sine and cos, the, the same thing which we did in the last problem, all right? So write in terms of cos theta and sine theta, it is going to be I, I'm taking this angle, I'm taking this angle as theta, 2 pi by n as theta, okay, pi by n as theta, so 2k theta. So I'll get this 1 minus cos, this will be alpha raised to k will be e raised to I 2k theta, all right? So cos 2k theta minus I sine 2k theta, all right, like this. And this product is there, k from 1 to n minus 1. And then simplify it, take this common, take club these two terms and these two terms, and apply half angle formula. So it is going to be product of sine, okay, 2 will come out, sine k theta will come out, because it is going to be 2 sine square theta, right? And the remaining, it is going to be cos theta minus iota sine theta. Now what you need to do, you take mod both sides, okay? Take mod of this. So after taking mod of n is nothing but n only, and this is product pi. Uh, Mod of 2 will be 2, mod of sine k theta will be sine k theta. Why? Because actually you can see this angle is always less than k theta is 2k theta is up to 2 pi, but k theta is always, k theta means what? K theta means k pi by n, and k is always less than n, so this angle is less than pi. And if this angle is less than pi, then k theta will always be positive, because sine is positive for all the angles less than pi, right? So you can remove mod from sine also, no need to put some mod, and then put mod only on this cos theta minus I sine theta, which is going to be 1, because under root of cos square plus sine square is 1. So actually you have got this pi 2 sine k theta, k from 1 to n minus 1. Okay, if you remove this, if you expand it, then what is this actually? This is cos, put the values of k and theta both. So if k is 1, theta is pi by n, so it is cos pi, sorry, sine pi by n, I'm sorry. So this series is basically sine pi by n. The next term will be sine, if you put k is equal to 2 pi by n, and then sine 3 pi by n, and up to where? Sine of n minus 1 pi by n, alright, like this, is equal to. Now 2 into 2 into 2 will also come with all the terms of sine. So 2 into 2 into 2, how many times? N minus 1 times. So it is going to be 2 raised to n minus 1, and divide this right hand side by 2 raised to n minus 1. So it is n upon 2 raised to n minus 1. This is a result actually, which you can remember. And similar result is with cos also. You can also get the series of cos in the similar way. But in that case, you need to put x is equal to minus 1. Because if you put x is equal to minus 1, these factors will become 1 plus alpha square, 1 plus alpha cube, and so on. So you'll get the series of cos also. So I'll tell you that also. You first understand it, got this series. So whenever you have sine, let's use it. For example, remember that n upon 2 raised to n minus 1, okay? Okay, sorry. That means if you have sine, this is the result, I'm writing it again, sine of pi by n, sine of 2 pi by n, sine of 3 pi by n, and so on, sine of n minus 1 pi by n. Alright, this is n upon 2 raised to n minus 1. Okay, this was the result you need to use. Alright, I hope you got it. So suppose that's like you have sine pi by 11 into sine 2 pi by 11. Okay, we need to find the value of this sine of 10 pi by 11. Okay, remember that up to 10 pi by 11. So what is this value? This is what? 11 upon 2 raised to 10. This is the answer. You can use it. Okay, all right. So you can use this series. You can use this result, important result. Yeah, remember this. Okay, so I'll prove one more result for you. Result of cos, which you can use in the next question. So as I have written, I'm using the same polynomial, same roots alpha. So alpha is your e raised to I 2 pi by n. So alpha raised to k is basically e raised to I 2k theta, where theta is same pi by n, all right, which we have used earlier. Then you can write x raised to n minus 1 divided by x minus 1 is equal to what? Is equal to product x minus alpha, all right, raised to k from 1 to n, okay, n minus 1. So this was the equation we used earlier, the previous question. Now I'm going to put x is equal to minus 1 in this. Okay, so if I put x is equal to minus 1, it is going to be minus 1 raised to n minus 1 divided by minus 1 minus 1. All right, and this is going to be now product of if you put minus 1, then minus will come out, so minus 1 will come out, and it is going to be 1 plus alpha raised to k, which you can simplify pi minus 1. Let's keep it inside, we'll take it outside later. K is equal to 1 to n minus 1. So it is going to be 1 plus cos of 2k theta plus I sine 2k theta, all right, the same way which we did earlier. Then again apply the formula. So this is going to be 2 cos square theta, 2 sine theta cos theta, 2 cos theta will come out now. So product minus 1 and 2 cos theta, and this is going to be cos theta plus I sine theta, all right. I guess. Now take mod. So if you take mod, it is going to be minus 1 raised to n, okay, and then minus 1 as it is, okay. In denominator, it's going to be 2 minus, you can cancel, all right, and then take mod of individual terms in product. In product, whenever you have mod of a, b, c, mod of this, then you can write product of mod of a, mod of b, mod of c. You can use this, all right. It's a product, so mod you can distribute. So it is going to be mod of minus 1, which is 1, mod of this number. So mod of this number will be 2 cos theta as it is, all right. Then this is going to be, what is this going to be? This is going to be 1, all right. So now you have got the series. Now you have how many terms you have? Same number of terms, n minus 1 terms. So 2 into 2 into 2, and how many times? N minus 1 times, you'll get 2 raised to n minus 1. Then this series is going to be cos pi by n, cos 2 pi by n, and so on up to up to where? Cos of n minus 1 pi by n. But you need to put mod in this case. Why? Why mod? Let me tell you why. Because cos of angle more than 90 degree is what? Negative, right? Cos of some angle more than 90 is negative term. So yes, in this half of the terms, at least half of the terms, if n is even, right? If n is even, then half of the terms will be negative, right? So you can't remove mod, it might be negative. So this is the result is equal to what? Minus 1 raised to n minus 1 divided by 2. Let's divide by, and you need to put mod here also. Now you need to put this divide by 2 raised to n minus 1. So finally you'll get this cos of pi by n, cos of 2 pi by n, and so on up to cos of n minus 1 pi by n. All right, is going to be 1 minus 1 raised to n. You can write like this, divided by 2 raised to total, it will become n. Now whether n is even or odd, you can decide, you can write about this series, you can remove mods according as n is even or odd, and also in odd you'll have to take 4k plus 1 and 4k minus 1, then only you can remove mod. So let me tell you how to remove it. I think up to here it is clear to everyone. Any doubts you can write in the comment box. Okay, so let me make some space here and I will write the results according to values of n, whether n is even or odd. Okay, so when n is even, okay, when n is even, then what is, when n is even, then you are going to get pi by n, pi 2 pi by n, pi 3 pi by n. Then somewhere you get pi n by 2 by n also, that will become pi by 2. Okay, from here also you will get that. So on. So first I am taking n is equal to an even number, 2k type, okay, or 2m type even. Then what is this result? Cos pi by n. Right hand side you can see, if you put an even, if you put n as an even number, it is going to be 1 minus 1 0. So cos pi by n, cos 2 pi by n, and so on up to cos n minus 1 pi by n is equal to 0. Actually what I was telling you, that if n is even, then you do not need to remember this series in this way, because if n is even, then somewhere in this series one of the term you will get as cos pi by 2, cos pi by 2, and cos pi by 2 is 0, right? because if n is even, then it is n by 2. N by 2 will also be an integer, and you are putting the numbers from 1 to n minus 1, so somewhere you will also put n by 2, and when you put n by 2, k is equal to n by 2, then cos k pi by n is going to be cos pi by 2, and then that will make the series 0. Okay, so in this way you can answer 0, or in that way, right, one of the term will make it 0. Now n is equal to an even number, odd number. So in odd numbers we are taking two types of numbers. One is 4k plus 1, and other is n is equal to 4k plus 3, or you can say 4k minus 1. 4k plus 3, or you can say 4k minus 1. Same thing. So let's discuss 4k plus 1. 4k plus 1 means 1, 5, 9. Because why I am taking 4k plus 1? Because if you take 4k plus 1, and how many numbers are there? These are n minus 1 numbers, right? N minus 1 numbers, you can see this. So out of n minus 1 numbers total, it will be 4k numbers now. 4k numbers in product, 4k terms in product. And out of 4k terms, angles in half of the terms will be less than pi by 2, and angles in remaining half of the terms will be more than pi by 2. So those will be negative values, right? And those negative values will also be even, because 4k, half of 4k is 2k, right? So in this case, this is a positive series, and positive, so you can just remove the mod. So left hand side, it is going to be cos pi by n, cos 2 pi by n, and so on up to cos n minus 1 pi by n. Okay, this is going to be, if you put 2k minus 1 in this, 4k plus 1 in this, it is going to be minus 1, and minus of minus 1 is 2, so it is going to be 1 upon 2 raised to n minus 1. Alright, 2 will get answered. But if it is 4k plus 3, then you will have total number of how many terms? 4k plus 2 terms you will have, right? So total will have 4k plus 2 terms, and 4k plus 2 terms. Uh, that is 4k plus 1, and 4k plus 1 will be positive, and 2k plus 1 will be positive. Total how many terms will be there? Now the series will have 4k plus 2 terms, out of which 2k plus 1 will be positive, and 2k plus 1 will be negative. So negative terms are odd number of terms, right? So now you get minus sign. So minus, the series will open with minus sign. If you remove mod, minus sign will be there. So pi by n, cos 2 pi by n, and so on up to cos n minus 1 pi by n. Alright. Is equal to 1 upon, what will be answer? This is an n is an odd number, again you get the same thing. So 1 upon 2 raised to n minus 1. So if you remove mod, this will be plus, and result will be. So you have got 3 results basically in cos series. That's the difficult part. But now we have got the results, so you can use it. Okay. You should memorize it. Truly, but it's slightly difficult, yeah, so far. So far, whatever we have done, it was lengthy as well as complicated to understand. I hope you won't get in. If you are seeing it for the first time, then definitely it is going to cause some problems. You'll see, what is this I'm going to discuss now. So these are the results. You can remember the results directly. Alright. Sometimes they can ask such series of causes, well, so you can use these results directly. But always you'll have to check this n, whether n is even or odd. In odd also you have to check whether it is 4k plus 1 type or 4k plus 3 type. Then only you will be able to answer. Alright. So let's solve it. Try this one. I hope you can answer this. Let's see. So let me solve it. First two options you can solve easily, because in first two options you can just let me write it. It's a difficult problem, but because we have discussed previous results, so we can solve it easily. 1 minus x into 1 minus, sorry, okay, so it was x minus 1 into x minus alpha into x minus alpha square and so on up to x minus alpha n minus 1, that was equal to x raised to n minus 1, right? So in this, if you put x is equal to minus 1, it is going to be minus 2. If you put x is equal to minus 1, minus 2, then it is minus 1 minus alpha, minus 1 minus alpha square, and so on. Minus 1 minus alpha n minus 1 is equal to minus 1 raised to n minus 1. Alright. If you take minus common, then how many minus will come out? So this minus 1 minus 1 minus 1, basically, and including this minus, it is going to be minus 1 raised to n only into 2, and now it will become 1 plus alpha square, and so on up to 1 plus alpha n minus 1. Okay, and it's going to be minus 1 raised to n and minus 1. So divide by this. So it is going to be 1 plus alpha into 1 plus alpha square and so on up to 1 plus alpha n minus 1. If you divide, so keep this 1 by 2 outside and divide by this minus 1 raised to n, so this will become 1, and minus will get 1 upon minus 1 raised to n, which you can take to the numerator also, minus 1 raised to n. They are reciprocal. I am saying this. What? I write it here. Minus 1 raised to n is basically minus 1 upon 1 raised to n. Because if you multiply and divide by minus 1 raised to n in this, multiply and divide, then in denominator it is going to be minus 1 raised to 2n, which is plus 1. So yes, you can always write. It's like this. Reciprocal of minus 1 is minus 1, reciprocal of plus 1 is plus 1, right? So minus 1 raised to n is nothing but either plus 1 or minus 1. So you can take the reciprocal of it. It is going to be the same. So yes, this is the answer. So which is the correct option? So now I can see which is the correct option. So answer B. Option B is the correct option, okay? Out of A and B. Now let's check C also. Okay. So in C is saying that this is the result. But we know that this is not the result, because if n is even, it was 0, and this won't give us 0, right? So this is certainly wrong. Okay, no need to check further. Now let's check this series, cos. So we have got this series cos of, let me write it, cos of pi by n, cos of 2 pi by n, and so on, cos of n minus 1 pi by n. Okay, I am writing all three results, alright. So you have three results. 1, 0, when n was an even number, 2k pi, alright. Then what was the other result? It was 1 upon, let me show you, this was the result when n was 2k plus 1, alright. So 1 upon 2 raised to n minus 1 when n was 4k, so not 2k, 4k plus 1, alright. And the next result was 1 upon 2 raised to n minus 1, alright. But I can see my video, I mean, in my mobile it is coming clearly. So I think it might be problem at, on your side, because I can see it clearly. But in my mobile it is very smooth. I'm also looking at the output, and this output is very smooth. I think it is on your side, certainly. Okay, so n is equal to 4k plus 3. This was the result. Now we need to check that what should be the value of n so that we'll get these angles, 4 degree, 8 degree and 12 degree, right? Accordingly we will write the answer as well, right? questions here. Shall I show you? See, I'm looking at my mobile. And it's perfect. See this? Perfect. All right. Okay, so what should be the value of it? Let's continue. I think, but anyways, thank you for the suggestion. Okay, so if I take n is equal to 45, because if I take 45, then pi upon 45 is going to be 4 degree, right? And 2 pi upon 45 is 8 degree and so on. Not 45 degree, only 45. Okay. So if n is 45, so we have got 45, then what will be the result? We can write it easily now. So basically proving part was difficult, but if you remember the result in application is easy, right? So we just need to figure out what is the value of n in this. Now see how easily we are getting the answer. Cos of 4 degree, cos of 8 degree, and so on. Cos of 88 degree, you can check, last term will be 88 degree. Now check which type of number is this, 44. So it is 4k plus 1 type, right? 4k plus 1 type. So what will be the result? 1 upon 2 raised to 1 upon 2 raised to wait a minute. This 4k plus 1 type. So 1 upon this is going to be 44. 44. Okay, but let me check the last time here. Because I just missed the last angle. Not audible. Is that so? Okay, let me check. But I can see, I'm getting my voice clearly. Maybe you need high quality voice, right? With it, I'm getting my voice, I'm checking it. It's quite clear. Yeah, really. So if I put n is equal to this last angle is going to be actually what? So last angle is going to be 4 into what? 44. So 4 into 44 is the last angle. So it is going to be 176. 176, alright. So 176. So it was series is folded actually. This is up to 88. So you need to fold this series. You can write this cos 176 as minus cos 4. Okay. But even if you fold, half of the terms will be negative and half of the terms will be positive. But negative sum terms will be even number of times because you can see these are 44 terms. So 22 terms will be negative and 22 terms will be positive. So negative terms will also will become positive, product of negative terms. So you can fold this series and after folding it, this product is going to be square of it and it is 1 upon 2 raised to 44. So it was really difficult problem. Now you can take the square root. So it is going to be 4 cos of 4 degree, cos of 8 degree. So you need to do such manipulations as well. Alright. It is 1 upon 2 raised to 22. Alright. So these are the correct options. options. So B and D are the correct options. Where is? Are you getting the voice now? Are you there? Okay, so I hope actually this part was really difficult. So I will suggest to remember these results. This result of course you have only one result in the series of sign. And there also you can fold the series. There are questions which in which you just fold. I mean you ask the product of half of the terms. So when you apply pi minus sin, pi minus theta, that becomes sin theta. You can use that. And there's no problem of minus sign in the series of sign. But in the series of course, yes, you have to take care of this. If your number of terms is 4k plus 1 times, there is no problem in folding the series. Terms will be, the terms which are odd will be even number of terms. So you can just take this product as positive. Alright. Okay, we'll do this problem now. Comparatively easy. Yes, there's some problem with the voice. Let me correct it. Okay, now let me check my voice if it is better. Yeah, actually there was problem. If it is okay. Mhm. Hello, 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 hello. So now voice is okay. Yeah, we got some problem in audio. Okay, so this is the last problem we are doing. After that, we'll end the session, today's session. how to do it. Okay, so first of all, you need to write, you divide by z. So if you divide by 2z, actually, if you divide by 2z in this quadratic, you can write, what I'm going to do is, you can see z by 2 in all the expressions. So first you take z by 2 is equal to x, all right? So you can read this expression as x plus 1 upon x the whole square plus x square plus 1 upon x square the whole square plus x cube plus 1 upon x cube the whole square, and so on, right? So using that, here also let's put z by 2 is equal to x. That means z is equal to 2x. So if you put z is equal to 2x, it is going to be 4x square minus 4x plus 4 is equal to 0. And now you know that this equation has two roots. X is equal to omega or omega square, right? So x is nothing but omega. So if you put in this equation, it is omega plus 1 upon omega is omega square, right? So a square, and then if you put omega in this, it is going to be omega square, and 1 upon omega square is again omega. So omega, all right, whole square, and this is omega cube plus omega cube. 1 upon omega cube is also omega cube square, and so on. So in this way, first just take first three terms. This is minus 1, so minus 1 square is plus 1. This is again minus 1 square is plus 1. But this term is going to be 2 plus 2, 4. 4 square is 2 plus 2, 1 plus 1, 2, and 2 square is 4, all right? So in this way. Okay, next three term will also give you the same value. First it will be 1, then again 4, and so on. So if you club 3 terms, then it is going to be, sum of first three terms is 6, all right? Then sum of next three terms is also 6, and how many total terms you have? You have total 24 terms, right? 24 terms. So how many times this 6 will come? Divide 24 by 3, so it is going to be 8. Okay, so 6 into 8 is going to be your answer, 48, all right? So that is the answer. I hope you got it. We'll continue complex geometry later in some other session. All right, it was in the roots of unity only today. So thank you very much for watching this video. Thank you very much. Like if you enjoy the video, and subscribe the channel